This is a short introduction to how to study and analyze different electromagnetic waves. There are two ways to look at different electromagnetic waves. The first is the time domain, and the other is the frequency domain. In the time domain, we view the waveform in terms of amplitude in volts and time in seconds, and this is what the oscilloscope is going to show you, amplitude and time. In the frequency domain, we think in terms once again of amplitude in volts, but this time in frequency. And this is what a spectrum analyzer would show you, amplitude and frequency only. To convert from the time domain to the frequency domain, it is first necessary to know the formula, the mathematical formula of the wave in the time domain. And once you know the formula, then you pass it through the Fourier transform or the Fourier analysis, as you can see in the diagram. And the result will be that out of the formula will come out the frequency in the frequency domain. A real audio wave from the human voice or from a musical instrument is very complex because it's a combination of several sine waves. And even though the sine wave is complex, there is yet of one fundamental, as you can see from the diagram. These adder sine waves are called harmonics, and they are multiples of the fundamental frequency. To go from the time domain to the frequency domain when dealing with the audio wave is broken up into small pieces. Then each formula of each small piece is run through the Fourier analysis. Then the result is that you can find the harmonics that are present in the complex audio wave. Notice that when dealing with audio waves that are based on sine waves, that there are even and odd harmonics. So for instance, if the fundamental is 1 kilohertz, the second harmonic would be 2 times 1 kilohertz or 2 kilohertz. The next harmonic is 3 kilohertz. Then the next one is 4 kilohertz, etc. An interesting thing occurs when dealing with square waves and triangle waves. Once again, if we know the formula for each wave and run it through the Fourier analysis, we find that these two waveforms have only odd harmonics. See, and notice once again, if we are dealing with a fundamental of 1 kilohertz, then you only have odd harmonics. In this case, it would be 3 kilohertz and 5 kilohertz. There are other waves, namely AM and FM, and also digital waves that we will look at later on, and they also behave in a very interesting way that can only be seen in the frequency domain, which is given to us by a spectrum analyzer. Once again, make sure to read the whole chapter and concentrate on the problems that are listed in the syllabus because this can be an interesting but difficult topic.